These are your 10-4B notes, solving radical equations again, but this time our radical equations may or may not include extraneous solutions. So it's just going to be the same thing that we did yesterday. However, how you get the solution may be just a little bit more complicated. It requires a little bit more work. And then you have to really be careful to check your answers, because now sometimes we may have to throw out one or two of our answers. And so when you, first of all, an extraneous solution is a solution that does not work after you check it in the equation. You did nothing wrong in the actual process for solving. You did everything mathematically correct, but for whatever reason, the solution doesn't work. And there's a lot of reasons that you'll get extraneous solutions, and radical equations is just one of those type of problems that actually lends itself to that. And maybe we'll talk in class a little bit more as to why that happens. So radical equations sometimes have these extraneous solutions. So if a solution is extraneous, it is not considered a solution. We throw it out. We don't write it down. We just cross it off. If you have two solutions and they both are extraneous, then it's no solution. So let's just try this a little bit. Same as before. We have to isolate the variable or the radical, which it is. So then we're going to square both sides. And when you square both sides of this equation, you're going to square that entire quantity, x minus 4. When you square the square root, they cancel. X plus 2 is equal to the quantity of x minus 4 squared. So I'm just going to simply get rid of the squared mark and rewrite it as x minus 4 times x minus 4. When I FOIL that, I get first term x squared, outer negative 4x, inner negative 4x, and last terms gives me 16. So I'm going to clean up that side. X plus 2 is equal to x squared minus 8x plus 16. And a little different than the example from yesterday when we had to FOIL, there was an x squared on both sides. In this particular case, there isn't. So the x squareds are not going to go away. And so we have to go into quadratic techniques. We can solve by factoring, we can solve by completing the square, we can solve by the quadratic formula. I'm hoping that we can factor or use the quadratic formula. Both cases, you need to make it equal to 0. So I'm going to bring over x, and I'm going to bring over 2 so that we have 0 on one side. And as I do that, I'm just going to switch this around. So I'm going to have 0, but I'm going to put the x squared minus 8x plus 16 equal to 0. Oh, I lied. Minus 9x and plus 14. I forgot to actually do the subtraction of x and the subtraction of 2. So all I did was I subtracted x, subtracted 2, and then I switched where the 0 would end up. So let's see if we can factor this. So I'm going to ask what multiplies to give me 14 and adds to give me negative 9. Negative 7 and negative 2 work. So this factors to x minus 7, x minus 2. So now we have a product that equals 0. Using ZPP, I can say that x minus 7 equals 0 or x minus 2 equals 0. That means x is equal to 7 or x is equal to 2. So my solutions right now are 7 and 2. I have two solutions. When I go back up to the original problem, we always check within the original problem. When I check my solution 7, when I check 7, I plug in 7 into the equation. And I'm wondering, is 7, the square root of 7 plus 2, is that equal to the same thing as 7 minus 4? So I'm going to simplify both sides. The square root of 9, is that equal to 3? That's what I'm asking. And the square root of 9 is actually 3. 3 is equal to 3. It works. So 7 is a solution. When I check positive 2, I'm going to plug in 2, take the square root of 2 plus 2, and I'm wondering if that is equal to 2 minus 4. 2 plus 2 is 4. The square root of 4, is that equal to negative 2? Well, I know that square root of 4 has two solutions, positive 2 and negative 2, but we're talking about the principal root. Is the principal root, which is 2, equal to negative 2? And that is false. And so this time we will cross off that 2, and we only keep the solution 7. So 2 would be considered an extraneous solution in this problem. I am just going to shrink my checks here so that they're out of the way. All right, so the next problem, we're going to do the same thing. We're going to square both sides because it's already isolated. Same process as before. That leaves me with x squared is equal to 6 minus x. Okay, that x squared is not going away, so I'm going to bring everything over to one side. X squared minus x, plus x minus 6 equals 0. So what I just did there was I added x to both sides, and I subtracted 6 to both sides to get everything over to one side. What multiplies to give me negative 6 and adds to give me 1? Negative 6 and positive 1. And so that's going to be 3's and 2's. It's going to be a positive 3 and a negative 2. That's equals 0. When you multiply a positive 3 and negative 2, it gives you negative 6. And when you add them, you get a positive 1. Using ZPP, x plus 3 is equal to 0, or x minus 2 is equal to 0. Therefore, x is equal to negative 3, or x is equal to 2. When I go back up to check my solutions, I'm going to plug in negative 3 and positive 2. So you always check with the original problem. So the original problem says that negative 3, or is negative 3 equal to the square root of 6 minus a negative 3, which becomes plus 3. And is negative 3 equal to the square root of 9? Is negative 3 equal to 3? And the answer is no. So you're looking for the principal root of square root of 9. I know 3 and negative 3 are both square roots of 9, but we're talking about the principal root. So negative 3 does not work. When I plug in 2 into the original equation, 2 is equal, or we're wondering, is 2 equal to the square root of 6 minus 2? Is 2 equal to the square root of 4? Yes, 2 is equal to 2. Same sign, same number. So my solution would be x equals 2. The other solution, negative 3, would be considered an extraneous solution. All right. I think you got the idea of that. We're going to skip number 3, and let's go on to number 4, a little bit more complicated with that fraction. So for number 4, I'm going to add 7 to isolate first. Get that radical all by itself. And so I get 5 times the square root of x over 3 is equal to 10. To get rid of the 5 times this, I'm going to divide all of that by 5. When you divide one side by 5, you divide the other side by 5. And so the square root of x over 3 is equal to 2. I'm going to square both sides of the equation to get rid of the radical. The square and the square root cancel. X over 3 is equal to 4. And then I'm going to solve. Right now, I'm dividing x by 3, so if I multiply both sides by 3, that'll get the 3 out of the denominator, and x equals 12. I need to check my solution. We always check our solutions. So I know I didn't stress it in yesterday's homework, but now that we understand that these things exist, it's always, anytime you solve a radical equation, you have to look. So I'm going to check my solution. I'm going to plug 12 into the original equation and see if it actually does equal 3 when we're all said and done. So I'm going to first do 12 divided by 3, which is 4. So I have 5 times the square root of 4 minus 7. I'm wondering, does that equal 3? That's why I put that question mark there. The square root of 4 is 2. 2 times 5 is 10. 10 minus 7, does that equal 3? 3 is equal to 3. We're good. X equals 12 is a solution. Okay, so I'm not going to say that every single one of them is going to have extraneous. It's going to keep you on your toes more. So now you understand that that concept exists. You have to check. And that was just a more complicated problem. So the problems are going to get a little bit more difficult, and that extraneous option is going to be there. So how do you know if a solution is extraneous? And then I want you to solve this radical equation. Good luck.